Good morning, everyone. I am Sheikh Mohammed Uzair, here to give a seminar on NoSQL systems. First, let's look at the history. The term not only SQL was originally coined in 1998 to identify a relational database that did not expose a SQL interface to manipulate and query data but relied on a set of Unix shell scripts and commands to operate on the text files containing the actual data. In a very strict sense, NoSQL cannot be considered a relational database since it is not a monolithic piece of software organizing information according to the relational model. Later in 2009, the term NoSQL was introduced with the intent of labeling all the databases management systems that did not use a relational model but provided simpler and faster alternatives for data manipulation. Nowadays, the term NoSQL is a big umbrella encompassing all the storage and databases management systems that differ in some way from the relational model. Two main factors have determined the growth of NoSQL movement. In many cases, simpler data models are enough to represent the information used by the applications. The quantity of the information contained in the unstructured format has grown considerably in the last 2 decades. And some of the NoSQL statements are document stores, graphs, key value stores. As key value stores, this is a micro classification that is further categorized into key value stores on disk, key value caches in RAM, hierarchically key value stores, eventually consistent. And last one is multi-value databases. Let us now examine some prominent implementations that support data-intensive applications. Apache CouchDB, Amazon Dynamo. Apache CouchDB and MongoDB Apache CouchDB 91 and MongoDB are two examples of document stores. Both provide a schemaless stores whereby the primary objects are documents organized into a collection of key value of fields. The value of each field can be of type string, integer, float, date, or an array of values. Amazon Dynamo. Dynamo is the distributed key value store that supports the management of information of several of the business services offered by the Amazon INC. The main goal of the Dynamo is to provide an incrementally scalable or highly available storage system. This goal helps in achieving reliability at a massive scale, where thousands of servers and networks components build an infrastructure serving 100 millions of requests per day. As you can see, this is a structure. Here is the keyring, failure and membership detection, request coordinator, pluggable storage engine, and one storage peer. The architecture of Dynamo system, as was shown in the figure, is composed of collection of storage peers organized in the ring that shares the key space of a given application. The key space is partitioned among the storage peers and the keys are replicated across the ring avoided adjacent peers. Each peer is configured with the access of a local storage facility where original objects or replicas are stored. Furthermore, each nodes provide facilities for disturbing and updates among the rings and detect failures of unreachable nodes. Now let's come to Google Bigtable. Google Bigtable is the distributed storage system designed to scale up the petabytes of data across thousands of servers. Bigtable provides storage supports for several Google applications that expose different types of workload, from throughput-oriented batch processing jobs to latency-sensitive serving of data to end users. Bigtable organizes the data storage in tables, which the rows are distributed over the distributed file system supporting the middleware, which is Google File System. Now here is big table architecture. You can see the table servers. There are multiple table servers encapsulating with table files, logs, graphics, and different databases. Now Hadoop HBase. Hadoop HBase is a distributed database that supports the storage needs of Hadoop distributed programming platform. HBase is designed by the taking inspiration from the Google Bigtable. Its main goal is to offer real-time data operations from tables and billions rows and millions of columns by leveraging clusters. Thank you.